Good afternoon, ladies and gentlemen. My name is Kadir. Today I am going to present a topic about my research, which is about network fault management. Specifically, I'm working on computer network faults classification using a hybrid technique based on fuzzy clustering means and probabilistic neural network. I would like to start with a simple introduction about the topics. Over the past decades, the computer network in different form of wire or wireless growth has a very rapid growth, and this growth affected the network fault management to raise the prominence. And with these topics, I mean with the network fault management, some techniques like clustering technique and classification technique, also some data mining techniques has become very popular to use in this field to classify the faults and to manage the faults. So one of the concepts in fault management is the fault diagnosis, which is very significant for the security and performance purpose. And as I mentioned before, clustering and classification techniques become more and more popular in this field. That's why I have choose the two techniques, one supervised technique, which is probabilistic neural network, and one clustering technique, which is unsupervised learning technique. So in my proposed work, I have chosen fuzzy clustering means as an iterative optimal algorithm to treat with the data naturally without affecting the other parts of data. I mean, the fuzzy clustering means cluster the data and get the optimal results for the data points and treat the noise data naturally without affecting the normal data. And also I use the probabilistic neural network. My aim for using this one to train the samples of the faults that we have, and also to identify, I will identify for all the faults that we have. My main aims and objective, I summarized my aims in 2 points. Firstly, the main aim of my proposed work is to develop and implement a highly effective tool to classify the faults that occurs in the system, and also to help the network managers to take a well-informed decision pertaining to the security or performance. And also, my second aim is to help the process of network management by avoiding the system breakdown, and also by predicting the faults earlier and identify the types of faults, and in some cases, especially for those faults related to the software, we can fix it automatically, but it's impossible to fix those faults that relate to the hardware. At least we need some human operation for solving these problems. And my objective is how to classify the computer network faults accurately. The importance and contribution of the proposed research. First, I would like to talk about the interest part of my research. Actually, for nowadays, the network fault management has so many positive impacts on the centralized management process by helping the network managers to classify and to point out every fault that occurs in the system. I'm just in my second year. I finished half of the second year, and I continuously updated my literature review from the previous research and study. As I have finished to now the literature review, all literature review that I have done it, most of them related to the system fault classification. Some of them they apply to classify the faults in industrial system, and some of them they are applying in the electric or some other machines. A few of them related to the software fault classification, and also I found a paper just about 2 or 3 weeks ago. They just worked on one fault, how to detect one fault and to recognize this fault. So, as I mentioned, there are so many research papers and journal articles about the system fault classification, but still there is a gap in the research in this field, which they don't involve to a computer network exactly. So, in my proposed work, I am going to classify those faults related to the computer, dealing with the routers, servers, and computers. So, to fill this gap, I used 2 techniques. I have chosen 2 techniques. As I mentioned before, it's a kind of semi-supervised technique because I combined one supervised with one unsupervised technique to fill this gap and to get a good and high-quality results for these papers. For now, for the current time, actually, I haven't used any statistical method to measure my methods. But based on some previous research, I chose this technique. For example, based on these papers that I have mentioned, they said that fuzzy clustering is a good technique for handling unclear boundaries. When you have, when there is no boundary for that any cluster in the clusters, you can use the fuzzy clustering techniques to handle, to solve this problem. And also it's useful to overcome the high dimensional problem. Another advantage of using fuzzy clustering means for this purpose is to get the optimal results, the optimal clusters, and also is flexible with treating with this kind of problem. Especially, it's one of the good techniques and more widely used for traffic analysis. And good points for second technique, probabilistic neural network. Comparing with some other techniques that they have been used for the classification purpose before this technique proposed, most of the research they used backpropagation artificial neural network to classify the faults. When the probabilistic neural network proposed, so some of the research have been done on this purpose, and they compared the result with the backpropagation. They proved that the probabilistic neural network has a faster training comparing with these traditional techniques. And also one of the most common and popular technique, which is base classifier, probabilistic neural network can't converge to this technique. There is a guarantee to converge to this technique. And also when you add some training data to the system, the probabilistic neural network retains the same speed without affecting the speed. Also, another good characteristic of probabilistic neural network is to dealing with the sample noise of data, and this one gives the technique to get accurate and high quality results. However, in my mind, I have planned it after maybe 6 months or 8 months to compare my result based on 2 statistical methods. The first one is entropy partition, and the second one is coefficient partition. These two techniques proposed by Bezdek, and it's a statistical measurements that they measures the efficiency, includes the performance and flexibility. So at that time, when I applied my technique to all faults that I have, I can use these two techniques to compare my results with some other traditional techniques to comparing the performance and scalability. This diagram shows an overview of my proposed research work, which includes in two parts. The green plug, this part, the green plug I mean, is the fuzzy clustering means part, and the other part is the probabilistic neural network part. I would like to generate and put some other diagrams, but I have no more space in my slide. That's why I just end it with this graph. I would like to simply explain about that, because in the next slides I will explain every equations in more details. So this one just shows simply you input the data here. When you input the data from the first step, the fuzzy clustering means initialize a membership matrix. This membership matrix means it appoints and it identifies the degree function, the membership degree function of each data points. Then they fit into another step, which is compute the cluster center. From that step also, the cluster center at the initial point randomly selected. But after that, based on some equations, I will show you later in my next slides. Also, we updated this one to just optimize the results. So the result moved to another step, the data moved to another step, which is compute and verify the termination condition. And at the last step, before moving the data to the outputs, we have two equations here to update the fuzzy membership and the cluster centers. And the purpose of doing that is just to optimize the results. So, after feeding the results to the output show us some data cluster points. Based on these steps, we can know that this group of data belong to this cluster and this group belong to this problem. But still we have the problems. We don't know what type of these faults are. So for this purpose, we used another technique to just train the data sets and train those clusters to identify the type of faults. So PNN, probabilistic neural network classifier, used for identifying and indicating the type of each faults that we have. Let's move to first part of my proposed work, which fuzzy clustering means. Fuzzy clustering means was originally proposed by Bezdek in 1981, and it basically relies on the measuring the distance to decide this data point belong to which groups, and also they measure the similarity between each data points, and when it says it's 1, it mentioned that there's a high similarity between these data points, and when it becomes to 0, it means that there's a high dissimilarity between these two data or two groups. And Euclidean distance is used for measuring the distance between each data points. And here I would like to explain in more detail about how fuzzy cluster works. First, the main equations in the fuzzy clustering depends on this equation they call objective function. And usually we are trying to minimize this function, because if we get a minimum value for this function, means that we get an optimal results of the clusters. These clusters, when you apply in such a program like MATLAB or some other programs that use for data analysis, it gives you 3 outputs. The first output is the membership degree. U represent for membership degree. it draws the membership degree for each clusters in each specific fault. For example, if you have 8 clusters in one fault, in one specific fault, it draws 8 membership diagrams for you. And also we have V. V here means for, we denoted cluster centers here by V. Initially, the V selected randomly. Later on, I'll show you in my next slide how we can update and how we can choose the best cluster center for each groups. And also we have the data points, X. So I'll show you in my simulation results.
Is that VJ actually VI?
Yeah.
Or something?
Yeah.
You've got V sub J, is it actually V sub I?
Which one? Here?
On the right hand side.
VJ? Script for V on the right hand side. Is it I or J?
No, it's I, sorry. I corrected, I don't know why I did not say it. Yeah, it's VI, because this one means for the clusters, and this one means for the data points. Yeah, you're right, thank you. And the main parameter in this equation is M. M is any number greater than 1. Actually, in the program, in MATLAB, this number by default is 2, but with the iterative, any iterative loops, it optimizes this result based on the faults. So here, M, call it fuzzifier value. It measures the degree of the fuzziness of each data points. And for the membership degree, initially, these are all selected randomly. But it should be, when you take the summation of all membership degree, it should be equal to 1. So for the generating the new cluster centers and to get a better results, because we selected randomly for the initial cluster centers, we used this technique, this equation, sorry, and this equation based on the also membership degree here, and the membership it takes from there when it updates the membership degree in each iterative loop. For the second part of my proposed work, which is I used the probabilistic neural network. Probabilistic neural network is a fit for artificial intelligence technique and is derived from the Bayesian network. It was introduced by Specht in the early 90s, and also it's one of the supervised learning techniques. One characteristic that distinguishes probabilistic neural network with the other techniques of artificial intelligence, there is no weight in the hidden layer for probabilistic neural network, while there is a weight for the other techniques in the hidden layer. But actually here, there's a training neurons. It acts like this weight. It acts the same function with like the weights. And also mainly includes, probabilistic neural network mainly includes the radial based layer and competitive layer. The main operation and mathematical equations happen in these two layers. However, here in pattern layer, the technique measures the distance between the vectors of the clustering vectors that we got from the fuzzy, and also the training data set, training vectors that we have in our system. So, as I mentioned, this one is basically include the radial base function, and there are so many candidates for radial base function. We choose a Gaussian function for this purpose, and Gaussian function for our proposed work here, I mentioned, is OJ equal to exponential power minus V2, and here V equal to, here this one means the neurons that train it, pre-classified our pre-classified data and minus by the clustered vectors multiplied by b. This b is the extended coefficient of the radial base function, and it relies on this equation. Here I think everything is clear to you. That maybe the split is not clear to you. I will explain what split means. Split here represents for a constant value, and initially this value by default is 0.1. If it becomes to 0, our result will be very selective. And when we make it larger, the split becomes unselective. And the first selecting of this value is determined by the training process. And this graph shows the general architecture of the probabilistic neural networks, which here there's no any mathematical equations, just inputted the data. When we feed the inputted data to another layer, which hidden layer, or sometimes we call it pattern layer, at this layer, these two equations will be applied, and after that, feed the results into summation layer. In summation layer, the result become into some classes, and these classes should be equal to our training class. And here it takes the summation. It takes the summation of this to feed to the output. At the output, it's selected the maximum one to compare the probability with the probability of training class that we have. Then after associated with the closest group of training data, it makes this group 1 to that associated group, and it becomes 0 to all other groups. So by the way, we know this fault belongs to which one, to which group of the faults. For the simulation, I used MATLAB to analyze the dataset faults, and this graph shows 4 different types of traffic. And for your information, for the dataset source, these data are collected by one previous PhD student who was finished his PhD in 2008 and supervised by me. His name was Muhammad Kassab. He just worked on fault detection without mentioning and classifying the faults. So he collected the data into different scenarios, light scenario and heavy scenario. These two scenarios means just can be created with the changing packet size and increasing the bandwidth. So he did that just for, in case if we change the data, or in case we change the bandwidth or packet size, is the system can detect this fault or not. So here it's just the data inputted to the MATLAB, and it shows this one from the top left when there's a fault with the traffic in bubbling node. Bubbling node means every fault related to Ethernet or every fault related to any protocols in your computer. So this one applied to router because we have more than this data, but I couldn't insert all my data into just a few slides. That's why I chose this sample, and we have some data tested with the servers in in light and heavy scenario, but I have chosen this one. So the second data shows the broadcast storm traffic in heavy scenario and also applied for the router. The third graph shows the normal traffic when there's just normal traffic, no any faults, also in heavy scenario in router. And the last figure shows the server crash traffic in heavy scenario on the router. So the next slide, this one shows the clusters for each data points, for each data faults and it shows how many clusters we have in each specific fault, and for all 4 different types of faults using fuzzy clustering means. This one, as I mentioned before, is the membership degree in each specific fault. It draws the membership degree for each clusters. For example, here we have 6 clusters, and also here also we have 6. And here it clusters the data into more than 6. So it draws the membership degree of each data faults. This one shows the index of each fault after using the PNN based on the training data that we have and comparing with the clusters that we got from the fuzzy clustering is. So at that step, the system will recognize that and will know that this fault belongs to which type and this fault belongs to which type.
What are the axes on the? I don't understand the graphs at all.
So these are.
What are the axes on the graphs?
It's just numeric. It shows the location of the faults. It's just a discrete numeric value. Just to know where the faults occurs. For example, here, the location of fault is different with this here. It's just the numeric to indicate the location of the faults. So finally, it's clear that fault managing with a great support and help for the network management process and help the administrator to take a well-informed decision on how to deal with the problems by identifying the faults and predicting the faults earlier, and also to keep the performance and to protect the system to break down. And we applied FCM and probabilistic neural network on the network data sets. And as I mentioned before, I have much more data than this, but I couldn't insert all my data into just a few slides. So the all data we have is 5 different types. Also I generate another data with the IP conflict. I have 5 data in 2 different cases. One is mine, and the other 4, the owner of data is Muhammad Kasab, it's not mine. And also I have planning to generate some other faults like virus fault or 0 faults, and all the faults are related to the IP. Maybe I have planned to generate some other faults that is very common in the computer networks nowadays. So the results in MATLAB revealed that the proposed application is useful to network administrator just by showing them in an output to show them the location of this fault and the type of this fault. And also the results show that different outputs can help the network manager to solve the problems in the network in soon as possible time. So by the way, it saves the time for them and also reduce the cost and keep the performance and also protect the security side for the networks. These are my 2 publications. One is published in Moscow in 17th International Conference about the distributed computer and communication networks. And the second one is a survey paper published in one international journal of advanced research on computer communication engineering. And this one is my poster just I have presented last week at SOC Student Research Conference. And this slide shows some of my references that I have used till now. Thank you. Any questions?
Yeah. I'll kick off with questions.
Okay.
Build on a question that Book Bind asked me about the dimensions that you're using.
Yeah, the dimension I say is just the discrete numeric value to show the location of the faults.
Yeah, but along what dimensions? You talked about different dimensions earlier.
Because it's non-linear problem,
Yeah.
it's not linear. I can't say this one is, for example, is time, this one or this. I just solve it the non-linear problem in a numeric dimensional data, and I just show the numeric numbers to know where this fault located.
Okay.
So this is represented just a discrete numeric value.
Okay, so it doesn't relate to any sort of dimension?
Usually these dimensions indicated in linear problems.
Yeah.
I think in non-linear it's difficult to say these dimensions for this is possible. For example, I haven't shown you some detected faults which I repeated from the experiment that Muhammad did. For those faults, for example, one fault related to the IP, it says this fault happens from this time to this time.
Yeah.
Yeah, but the problem is linear. But if the problem is non-linear, I think it's difficult to. That's why, and there's no any purpose to indicate that.
Yeah. If I can still another question as well then. Is this intended to work in real time?
Yes, real time.
Yeah. And will it be able to pick up a new type of fault? Because you're classifying all these different types of faults. Will it be able to bring out a new type?
Yeah. Also, I have planned to add some other faults, and also in real time how to detect these faults. And one of the purpose of selecting probabilistic neural network,
Yeah.
I mentioned before, when you increment any training data,
Yeah.
this technique can retain the same speed to classify those data.
Right. Which goes back to my final bit from that. How do you actually bring in the new faults detection into your model? Your model seems to be having your training data, and then you have this classifying.
Yeah.
So
At least we
so
need.
how do you actually bring in the further training to actually identify the new one?
Yeah. At least firstly we need to provide some new tools for each specific fault. For example, these faults are collected by special tools. One of them is DOS HTTP and one of them is V2LAN. So at least I need firstly to generate the faults with this, and from the program direct this fault into our system and detect it, then goes to another steps.
Okay.
Just a question. Where's the academic novelty in your research? For PhD, it's very important to show
It's a question.